Today we are on chapter 12, array of objects. And right here, the rest of the book, chapter 12 to 14, is 12 to 14 representing the OOP, object-oriented programming, and representing the inter-class relationship, different class relationship. And chapter 9, 10, 11, mutable, immutable object, and also the design of class. These three classes talk about the design of a single class. And now in 12 to 14, it pretty much explore the class-to-class relationship. So what are the topics actually will be discussed, and it is needed, required for AP. And that will be covered in chapter 12 and 14 right here, including the data structure, array of object, object of array, array list objects, object-oriented programming basic idea, encapsulation, inheritance, polymorphism, and static binding, interface, GUI. This one is not AP tested, but it's very important for OOP, object-oriented programming, and algorithm that actually will be tested in AP course. But since Java doesn't have a good organization for this, so usually up to this point, I think your introduction to Java is completed. But I will continue to teach you on this course, okay? Finish up 12, 13, 14. But the material in this course is not the best organized material. So we will actually review it when we go to our AP CSA course for the coming winter quarter. Actually, it's in B course, okay, for similar topic, but it's much better organized in my video course. Okay, but this here actually, it pretty much cover many of the topic, but it actually scattered around, not really well organized in Sing Java, but Sing Java's first 11 chapter are better organized. Okay, so now let's get started for this chapter 12. Actually, it's an array of objects. It's actually an array of objects. It's an array of objects. We talk about array of objects. So first, we have a single object and many objects. It's created by a class. And now we're talking about array of objects. So let's talk about some poker card. So poker card, each card can have one object. If we want to define a class to represent a playing card or poker card, it is pretty obvious that the instance variable should have two variables. One is rank, one is suit. Have you ever played poker card?
I think so, yeah.
Poker card, and you know what they have?
Yeah.
Okay, so one obvious possibility is using string that contain spade for suit and then queen for rank. Okay, a problem with this design is that it would be easy to compare cards to see which higher rank than suit. An alternative way is to use integer to encode the rank and suit. Which one's better? Of course, using the integer would be better because it's shorter and more concise. Okay, and then by encoding, we don't mean that encrypt or translate into secret code, but it's just some integers. We mean the definition between the sequence of numbers and the card we want to represent. Okay, now let's page. So here we actually will have 4 cards. So this one is 3 of hearts, 3 diamonds, 3 club, and 3 spades. And then rank is the number, or the JQKA stuff. That's rank. And suit is the type of card you have. Okay, so and this is called. This is not a deck of cards. This is actually a hand of cards. 4 pieces of them or 5 pieces of them, we call the hand. And then the whole deck means all the 50 cards are a deck. Or sometimes you have a joker card also included. For some game, the joker card is also included. So here
Yeah.
we have an encoding for rank and suit. Okay, so here actually the encoding right here is talking about some string. So in order to access a file that's a G file, we need to have a number and then the suit and then .gif. Okay, let's look at our card. Let's look at our cards. Okay, so here is like chapter 12 project. And if I come here and then go to my file, I have a Java course, Sing Java, and then project, and then example, and then chapter 12. Okay, there is a theoretical cards. And under the card, I have these different cards. I have these two clock. I have two clock of the reverse two cards. So what's the reverse card for? What's the reverse color card? Black card, reverse one for? Two diamond reverse. What's the reverse card for?
A different deck.
No, different. It's not different deck. It's actually used when sometimes for them playing, right? He has some card over here, and this guy has some card over here. And for some game, actually, you have a replacement. Once the card got replaced, it's thrown out to other side, like a garbage can or something. Then that one need to be in reverse, so people know that these cards are not in power.
Oh.
Okay, and this one white card actually is an active card, and there is another one. This one, what's this one for?
It's the back of the card.
Yeah, it's a backup card, so that means that a card is not been revealed. It's not actually shown. Okay, so for some poker game, you need a backup card, and this one is what? Joker card.
Jack. Oh, okay.
Yeah, Joker card. Jack is
Yeah.
different. Jack is
Oh, yeah.
is down here. Jack, Queen,
Yeah.
and King are down here. Okay, so
Okay.
that card, two card are Joker card. So this is a whole set of the card, and under this chapter 12. Okay, and then maybe some of your course may need that. Okay, later if you need that, I would give it to you for the card anyway. So each file you have the number and the suit, and then I need to actually assemble the number and the suit and the extension so I can get a string, and that string actually can be accessed the file image. Okay, then I can assemble that and get an image. So a file name is a rank plus suite plus extension string. I can open that. And besides that, I can also define suite S for string. Okay, here S for string. So actually, I can have this string, and these are actually using these, and I can have a rank. Rank can be a string as well. Okay, but I can use another system. I can use this one space as a symbol. So this one actually is a symbol. So if I copy and then I put it here, excuse me. This symbol actually is a ASCII symbol. So I can actually show the ASCII code for this one. 153 is a clock. So if I push a little bit, I hit Alt 153. This one is not. So let me see. This one is ASCII table. Let me use the. Don't call it the ASCII code. Let me try this one's Unicode. Maybe it changed. Okay, try this one's Unicode. So the Unicode for this guy, wait, okay. Unicode for this guy is 2663, okay? Unicode is 2663. So let's go back to our program. So right here, I have a simple program. So let me try this one, suite. Okay, for suite. And then here, let me actually delete all this. And then public static void name. And right here, I type base u, base slash u, and then 2663, and then I compile and I run. That will give me a clock. Okay, that's a solid clock. Now I need more things. So this one is a clock. So I need actually I need space. Okay, that's what 2660. I need diamond. Diamond is 2666. Black diamond 2666. And the space, I need to have a space. Space is, let me see, I want to have a black space. So here, let me say black space. Black space is 2660. So 2660, 266. And the diamond is 2666. Let me see. Okay, something like diamond. Black diamond is 2666, and then I still need to have black heart. Black means a solid color, so 265. Okay, so right here I have, so starting from space backslash u 2660, and then heart backspace 265, and then clock to diamond backslash u 2666, and then clock at the end. So here, actually, this file, I keep track of the phone numbers for that different number. Oh, this one is wrong. Okay, 265 is not actually a very hard. So black heart, I don't think black heart, I don't think it's 265. Let me try with something else. Actually, I don't want the heavy one. I want the light one. So 265. Oh, I miss a U. I'm sorry. I miss a U. So let me put the U back. So nothing wrong. Okay, the four colors are here. And then if you need the white one, so let me try this white one and say Unicode. So the white one trading card Unicode. So here has the Unicode. Oh, so the white one are these different numbers. So let me copy this down. Okay, spare hard diamond. Okay, copy this down. This is better. Okay, this one is better. So let me just put it down here, and then I use backslash u. And then here I have backslash u, okay, and backslash u. So now I collect both the black one and white one. I collect the information for black one and white one for layer suit Unicode symbol. So you can actually treat the symbol just like a string now. Okay, you need to print that onto a screen, or if you want to draw some something. Oh, not something wrong. Something wrong. 2661. Let me see. Let me check. 2661 is, yeah, 01, and then 2 3. So what's wrong with that? Yeah, so this one actually should be fine. And how comes that very hard? Let me show. Let me try one more time. Compile. Okay, I think that symbol corrupted or something. Or I type in something wrong. Okay, let me try again. Backslash U 2661. Okay. And this one. Oh, okay, whatever. Let me, I don't know. I don't something wrong. Let me change it to X, see if it works. Okay, it doesn't work. This X. Okay, I'll check this Unicode, but I grabbed it from internet. It should be the 2661, but somehow Y1 doesn't work. Okay, even every car, every poker car has its own Unicode. Okay, but I don't recommend that because that's too small. Okay, now we are back to here. So we have this different car through the number we can play around. So you need to have a system by yourself what you want to have. Either you use string or you use you would like to use string or you like to use symbol. That's up to you. But here, if we use the suit for the file name, you definitely won't use a capital suit. Okay. And then if we use the number, we want to have 0 to 13 to represent each rank. So we actually have the rank 0 to 13 plus 1, that's your rank. Okay, if you take modular. And the 3 would be the I divided by 13. Okay, so I have a deck. I start in no matter from club or something. Okay, so here in the system that the textbook use, it's using club as 0, diamond as 1, heart as 2, spade as 3, and ace as 1, king as 13. So you basically encode the number into this. So it actually is like 3 times 13 plus your rank minus 1. Okay, rank minus 1 is your car ID. Okay, if you look car ID is something like this, a certain car ID something like this. So to get suite, you actually do ID divided by 13. Okay, to get rank minus 1, you do ID take modular by 13, and then rank is equals ID take modular by 13 plus 1. Okay, that's what it is right here. So that's the system the textbook use. Okay.
Okay.
So this one actually the remainder is actually 0 to 12, but we plus 1 become its rank. Is that okay? But the number we run from 0 to 51. Say now if we have someone called 47, right, divided by 13, we got 42. So we got 3, right? Remainder 5. So that's a rank minus 1 is 5. So rank is 6. So this one 3 is actually spade 6. Okay?
Okay.
That one is a space 6. So that's the system this textbook use. So for different system, you can have different suite or different number of assignment. That's up to you. So here, if you get this space, the file will be 6 and no space in between. Okay, it actually is 6 and then space dot gif. Okay, you need to use that. So here is a different file name that will have it. So basically, you have the car, you have rank suit, and then you have rank suit or whatever. That's car class. Okay, and then you would have an ID as well, and then ID is in the deck. Okay, so the instance variable are private. Okay, so each of the class you can assign the suite and the rank in order to get it. Okay, suite and the rank. So this one is a suite of class. Okay, now let's look at the code. So here I need a car class. This car class have a rank of null for 0, A, so this is 1, A is 2, 3, 4, 5, check whatever, a suite like this. So this one are public constants. So this one are class variables, right? So people can always access this string. And then we have rank suite, and then we can compare to a certain car. Whoever have a bigger ID actually will be bigger. Okay, that's what compared to. Equal to is equal rank equal suite. Get rank, you get its rank. Get suite, you get its suite. Get suite. And then the position is the ID. Okay, you use the suite times 13 plus the rank minus 1. Two string, something like this. That's a card. So here I have a search program. Okay, so basically this search program. Okay, let's go too far. Okay, let's go too far. Let's not look at it. So let's finish the car object. Okay, it's done. The next one, car to string. So each one I need to print it. So I want to have actually I have this suite, and this is suite, I assign a suite name, so that's fine. So in our code, serialize the index. So I have a directory name called this. I have an extension called this. I have a capital suite and capital rank like this. So these two and these two are used to find the suite class dot gif, and the file directory is called cars. So we can use that to open the image file, and that's what I just show you. That's what I just show you. Right here, I have a subdirectory called cars, and in cars, I have so many different files in there. Each one have a name for the cars, so that's fine. Okay, the next one, I have a suite, so my suite is an array of 4 strings, so that's fine. The next one, I have the rank, same thing, we see that. And then two string actually, I use the cars rank to get rank. Ranks is the string. So this ranks is the string. This rank is a string. So what's that? That's the crop diamond things. And this rank is a number. And here I have a suite. Suite and the suite number 0 to 3. Okay, this one is what? 1 to 13. Use the rank number to get that. Okay. So that's the toString. I'll convert it to a S, and that is whatever it is toString. And the next one, I have toString function, have this rank, and then use this and return that S. So that's a simple toString function. So here I can create a car. One is what? Heart or something. And then 11 is 11 car, so it's jet, so it's like heart or jet or something. So that is Okay, that's toString, whatever. That's CarString class. So that's that. So now let's look at the CarString.java. So here I have CarString.java. CarString.java is like I have a rank suite. Okay, I have a special to string and to long string and to string. Okay, so to long string have an off there. If to show string, it will become a string for file accessing. So here has a main function. Okay, from 0 to 51. Each one actually I'll try to actually do this. Okay, and then do this. Okay, whatever. That's just run this car to string. And the result is I traverse through all of the 13 different cars. So actually, let's check it, okay? Car to string, the first for loop traverse to all of the 52 cars, okay? And then I get car string, the number and rank, okay, the number and rank. And then actually I just print that one. Print that one I use what? I use toString. toString is a show form. Show form will give you the lowercase 3 is the symbol and the rank is the number. So let's look at the show serial index. Serial index 1 has a capital 3 for the full string, lower rank each symbol for each letters. So 10 actually I use the Unicode 241991. So that one is a 10 with a dot, but too bad I cannot find a single symbol with 10 in there. So this one is only to show a short representation like this. So I go through the 54 card, and then I use the long to string form, that actually using the ranks, capital ranks and capital suite. And that one actually each one card I to long string and actually will print now each one in one line over here is actually something like this. Okay, so that's car string to convert car to string, and then sorry. And then next one is a show car on canvas. Try to draw it on canvas. So to show car, I have a show car. So let's look at the show car. Show car first at the beginning. I'm sorry. At the beginning of file, I need to import Java AWT graphics, right? What's the graphics for? Still remember that? What's the graphic for? What is the graphic class object for? And what's the JFrame, JPanel? Still remember that? And color, I know you know. Okay, color, I know you know. How about this four turns? Still remember that? Remember we in last week we talked about no, not 2 weeks ago we talked about the block, right? I have a block, flying block, and Mickey Mouse stuff. Remember that one?
Yeah.
So what's the big window? What is the big window stand? That is Blue Jay window. What's that?
The output window?
No, this one is a frame.
Oh.
So JFrame is a new swing frame. Okay. What is something we want to draw something on it? What's that? Inside the frame.
The panel?
Yeah, it's a panel or canvas. Canvas is the older version. Swing, we use the J panel. Is that okay?
Yeah.
And then what's the graphic? Now you remember that? Or no?
The things you draw.
Actually, it's the
on the panel.
The paintbrush. It used to set a color and whatever.
Yeah.
Okay, so that's that. And then to hold a card, you need to have something called buffer image class. Buffer image class is to hold a picture of somebody.
Mhm.
Okay, or to hold a card image. Okay, that's called buffer image. Now, so these are the classes we actually have. Other than that, those are helping one the auxiliary files or class. Okay, that's not that important. We need that. We will know that. Okay, anyway. So we have a buffer image for each car. We have a buffer image called IMG. This one is to hold a certain image. So now, when we construct a card called show card, we will read the file from the serial index get file name 33. So file name 33, and we will get a name for it, and then we will use that to get a file for it over here. So 33 should be rank 3. 3. The first 3 is 3. 3 is space. Okay, so set up the car to be space 3 and see if it's successful, we will let it pass. And that's the buffer image. The buffer image class has a constructor that set out an image for a club, a space 3. Okay, and then our main program the same. Open the window 200, 200, and then we have the JFrame title the show card, and then we use the show card constructor to build a image and then assign that to that drawing to a canvas, and canvas and JPanel is the canvas we want to draw something like it. And then set aside with the width and height, set the background color to gray, set the preferred dimension WNH, set the resizable to be false. You cannot draw or move your window, add the canvas to the frame, and then set close, unclose button. That's the right hand side, the close button over here. Set it visible. And once you have a constructor set visible, the pane will execute once. So you will actually run the pane for graphics. And then if the image is not null, we will get the center point for the x and y, and then calculate the top level. That actually is the left. It's a left top corner of the point xy, and then here is image, and draw that image on current canvas. Okay, now that's it. Let's compile. Let's compile, and then show card. Okay, that's a space of 3, right? And then if I don't like it, I want a diamond. What should I do? Diamond or 3, what should I do? 3 change it to 2. Okay?
Okay.
And then oh, 2 is hard. I'm sorry. Diamond probably is 1. Okay? Let me check my system. I probably made a mistake over here. Okay, hard is 2. Okay, diamond is 1. Okay, so actually 2 is for diamond. So if you like it here, let me show card this time. Not here. So hard Kim say. So hard Kim is 13. Okay, so this one show card would show this. Okay, so what here actually is a little bit more advanced from the block game. It actually show you the cars suite and ring on the panel. Okay, on the panel loaded to canvas. This one do something to canvas, and this one do the pen function, and you can show whatever car you want to do. Okay, and let's reset the number back to 33, because sometime later we still want to show other people with that. I don't want to corrupt my database. Okay, set it there. Now this one, car image class with image. So the one is like I have a separate show car, and I also have a class called car. So this show car and car are now in one class. So I set a new class called car image. So this one come with the rank and with a data called image. So I associate with the rank suite and my own image into a class called car image. So it's a has an image car that has an image, and then I can do two long string and two strings. So this one has a combination of the whatever. There's a combination of the serialized index to get file name. So serialized index actually is helping you to get file name, to write file name that has a directory range suite and extension to get a file, okay, or get a symbol. So that is a service class. So now I want to show my car. So here actually I rewrite that one car image show car, combine the show car and car into car image, and then I use show car image to replace that. So that one, actually that's wrong, that one. So this one, when I show car image, it actually is the same. But the two class, show car and car, are combined and using this one to draw it. Okay, so this one a little bit better. This one is a little bit better. Let's try this one. So car image, I can show the car, and then this pretty much is similar. And then this one, class variable constant. I told you like, at least I told you already, so that's not important. Let's move on. Demo program car static. Merge constant and static method from serial side class to this class. So now I don't want the serial side class to be outside. Okay, so I move this service function and everything into a class called show static car. So I have a car static that's improved from the car image, and now it become a car static because I put every of those static car to be here, get name, get file name, get symbol over here, and then normal car image files data over here, right? So now it's a more complete class, and I do the same job to show my static car. Okay, my static car, I can show the car, but now I group the serial index car, show car, and car image into single class. Okay, and in fact, if you really writing a car game program, you can basically take out the static. Okay, that's just to keep track of different version, image version, static version, or normal class car version. Okay, so that one is a car, static car, I'm sorry. So the next one, okay, that's the static car.java. And then I merge a few class together. The next one is immutable object. Okay, now I want to make a class that's immutable. So every data field, there are three rules I talk about. One is every data field need to be private. Second, they don't have the mutator or setter. Third one, any access method cannot return a reference, so that make a class immutable that you cannot change. Okay, that's something important. So for doing that, we actually make our immutable. So the instance variable, these are private, and you can only get these from here, and they are only numbers. There's no reference for it. Okay, and then make data field final. Final, you cannot change the rank or suite. So once you assign it, you can no longer change it. So here we have car immutable and show car immutable. So this one is somewhat improved from car static. Okay, but it makes things immutable. That's the only thing it achieves. Okay. Other than that, when you show it, it pretty much is the same, still the same image, just to add the immutable feature in there. Okay, so that's nothing special. The next one, compare to method. So we write the compare to, and last time I show you the compare to, and then we can actually sort the program, right? Remember that?
Yeah.
So this one we write the equal. So same rank, same suit, that's equal part. And then we try to set the order, and the order can be sorted by to compare to. So now let's look at compare to. Compare to, you basically, if a certain car has a higher suit, then the other car has higher suit, then my current car is smaller, so I return the minus one. Otherwise, if actually my current car is actually 3 is greater, then I return one I'm greater. Okay, same for rank. And if we compare 3 first, so higher 3 already take out higher number. Okay, that's fine. So we have to compare two things. Okay, and then we can implement T, that's generic. You can change the different class, which that's a data type class. So now my car compare the new car class. Let's compare version. Add this compare two function in there, and then let's see it. Okay, so I have a car compare. I have car compare right here. I have this one's a car with a comparable interface in there, and then here I have a car to compare. So let's look at this. I use a random number, right? And then I actually generate 4 different cars, 10 different cars, and then these 10 different cars, I actually create a car into uh, create a car into the array, 10 different cars, and 10 different cars use different rank, random rank, and random rank, and random street number. After that, I print it out and then I solve it. Okay, so let's see how this test compare function. So original car is like this, a handle car is like this. Then I solve it. So this one is in the order. Okay, so crab is smaller than diamond and heart and spade. And the number smaller is left hand side, bigger one on the right hand side. So it do sort, okay, it do sorting for us, and that one is okay. Now let's try next one. That one is fine, and this one's compare function, okay. The next one, I have an array of cars. So now I have an array of cars. I can put all of the 52 cars into a deck or a cars, array of cars, and then each car need to be instantiated. So each one I need to hang the car in there. So an array of car actually is array of some references. So car C cars equals new cars 52. This doesn't actually hook up the whole 52 car. In fact, it's only a 52 slots. Okay, so each one like CS0, I still need to new a car for it so that I will hang a car over there. Otherwise, it may be empty. Maybe empty. If you don't hang the car over there, it may be empty.
Okay.
Okay, that's what we talk about the array of object. Okay, so let's look at the code. Like look at the code test car compare. Look at the code. So here I create 10 different cars. After that, this one is only setting up 10 different cars. It's only 10 different car location, and each one I need to put a certain car in there. Okay, and then what's the difference between this number 2 and number 1? It looks similar to me. Oh, I can print a whole deck of cards. I had to print the whole deck of cards. So I can do sorting and actually this, and I can also print the whole deck of cards. So this number 2, I had a printing function, okay. I can actually do print by list or do printing the whole deck, okay. How about number 3? Number 3, actually do searching, okay. Number 3, do searching. Let's go back to our slides. Now, the next one is the searching. The searching function, okay, and then how to convert 2D indexing into 1D. Okay, this one actually we have like, what is 2D function? 2D function is like I have a deck of cards, right? Each one different suit. So I have 0, 1, 2, 3, right? And then the index 1, 2, 3, 4, 5 to 13. That's 2D array, right? 2D indexing. So I can convert it to 1D with what? Suit times 13 plus rank minus 1, right? That give me my single ID, I, right, index I. And then if I need to convert it back to 2D indexing, then suit will be I divided by 13. And then rank will be this index number 10 modular by 13 plus 1. Okay, here are conversion from 2D indexing to 1D array or 1D indexing to 2D array. Is that okay?
Mm-hmm.
So that's that. That's the conversion for that. So later we need to do more homework. Okay, this one just give you some idea. Okay, so this we create all the. We use I to create all the possible I number and then convert it to rank and suit and create a new card. So this one actually creating 52 card and it's starting from club 1 to club 13 and then diamond 1 to diamond 13 and then hard 1 to hard 13 and then finally with spade 1 to spade 4, 13. Okay, so that create a whole array of cards in 1D order. Okay, that's that. And then each of the card is something like this, holding a card under it. Okay, and then we print that. I show you how to print it already. Next one, sequential search. Now I want to search sequential search. So I will just do sequential search. What is a sequential search? Okay, I don't want to do this card. So what is a sequential search? Sequential search is when I have an array and I want to find out the ID for a certain card. Are you all right?
Yeah.
Can you still stay awake?
Yeah.
Okay, hopefully we still have a few topics to talk about, then we will finish. Okay, just hang on. So now, okay, what's a sequential search? For example, I have an array, static integer array, and then I have this one a equals, I have different number. Okay, I have this different number. So I have 3, 6, 4, 2, 7, 1, 9, 10. Okay, and then I want to find out, okay, so here I have a function called search. That's a sequential search actually. So give me a number called, then the number can be called key. I would like to see if this key is in there or not, okay. If not, I will just, I would say, if not in there, I will just return -1. Okay, if my key is not there, I will return -1. Now, so here, let me say, okay, let me set the index, default index to be -1. Okay, so at the end, if index is not changed, I will return index that would be -1. Okay, now I would say here for int I equals 0, I less than what? A dot length, A I increased. Okay, so if A of I equals key, then I will just return key. Okay, I'll just return key. And then this one, actually, I don't need that. Okay, actually, I don't need that. So if I use all, then I still cannot find my key. Okay, no, I don't return key. I should return I. If my A of I actually is equal to key, I'll return I. Okay, otherwise I will actually return -1. So right here, let's do this. First slash F, and then right here, let me do this. I will do search of 6. Okay, search of 6, I should return 1 because 0, 1. Okay, 6 is index 1. And then I'll do system.out.println, and I do search of 5. 5 will be missing, okay? And then I need copy more. What's wrong with that? Oh, this one need to be static. I'm sorry, because the main function using it. So Nabi copy all these, and then I change it to 7 and 10, okay? And see how this different number work. So this is called sequential search or linear search. Okay, to search some number inside a array, that's called sequential search or linear search. And let me run it. Okay, got a result. Okay, so here let me put something like this. Usually, if we have something to search, I will do this. I'll do this. So here I put in /0, 1, 2, 3, 4, 5, 6, 7. So let's look at the index, whether it actually has the right index or not. Okay, so 6 is 1, that's correct. 5, you cannot find it, that's correct, -1. 7 is 4, that's correct. 10 is 7. Okay, so this linear search actually works. Is that okay?
Yeah.
But you need to remember this linear search algorithm, even though it's quite simple. This one is AP tested topic. Every year, you probably read 1, 2 questions on this linear search, even though it's quite simple. Okay, remember that you need to memorize the whole thing. Is that okay?
Yeah.
Okay, so this is linear search. So if I want to, I got an array of cards and I try to actually see my target card is in there or not. Okay, in the deck of cards. So if 2 are equal, then I return I. Otherwise, I return -1. Okay, that's called linear search. So I finished that. Another one is called binary search. Binary search is more difficult. So here actually has some algorithm. Let's compare 3. Okay, so let's look at the code directory. Let's look at the code directory. Okay, this one is a linear search. So far, we have a linear search. Now, what we will do is to do binary search. So binary search, we have that one compare 3. Now this one compare 3. Okay, so this one is a compare 3. So right here, I'm compare 3. I have the linear search function for the car. Here I have a binary search. So what is binary search really is, this binary search is faster than linear search. on the average, but not every time. Okay. So what this binary search is like, I need to have my car sorted. So say I have 1, 2, 5, 7, 8, and 9. Okay. Now if I have a number 4, I as a key I want to search. I start with my middle point. My middle point equals 0, 1, 2, 3, 4, 5. 0 plus 5 divided by 2. So that gives me 2. Okay, it's a 2.5 by integer. So I started with this one. So my 4, is that actually equal to 5? No, I will check left side. My 4 is smaller. So now I will use 0 and 1 because this part no need to test it. So I use this one 1 divided by 2. That one give me 0, so I will test this one. No, it's not there, so I will try next one. Using this one, only 1, 1, so 1, 1 divided by 2 is 1, so I test the number 1. Actually, it's not meet, so I run out of my candidates, so I will return -1. Is that okay?
Yeah.
This is called binary search. The good thing about binary search is that it's faster than linear search on the average. So let's do this 1, 2, 5, 7, 8, 9 again. Okay, if this time I need to search for 7. Okay, this time I still starting from this one because the 2 this like 0 plus 5 divided by 2 still be 2. So I started from this one. Miss. So I started with 3 and 5. So 3 plus 5 divided by 2, I get 4. So I get this one. Miss. So the next one I'll do, this one will be 3 plus 3 divided by 2. I get 3. I have a match. So I search how many times? 1, 2, 3 times. If I study from the lab, I need to do 1, 2, 3, 4 times. So green one is better, faster. That's what we say. It's a binary search. When the number go to like my array is of 2048 element, that's 2 to the power 12 number, right? So the first time I divide my group into 2. So it's only 10, 24. And then the next time I divide it into 2, it's 5, 12. Either left side or right side. So totally, how many steps I need to actually, on the average, I can find a simple. Worst case, 12 times I can finish that. But if I use my linear searching from 0 to 2048, or the worst case is 2048 step in order to get one. So who is faster? This binary search is faster. But binary search, you need to arrange your number in sorted format. That's one extra cost. Is that okay? So lecture 11, we are about to end this chapter. Lesson 11, trace code. What is trace code? Trace code just you need to study all the code you have line by line to study your code, to understand how your code works, and being able to draw some diagram like I draw for the binary search. That's tracing code. Step by step, keep scoreboard, try to understand what the goal work is called tracing code, okay? And then I can have a recursive version for binary search. Okay, this one is too much, so I will omit it here, okay? But you can read these slides and download the slides from internet. The last one, generic, is to provide a generic searching type so that the binary search can work for car, for integer, or for every other things. So here, let me show you what's the generic searching type. So generic searching, here, I allow a T type. Any T type can be sortable. So here, actually, I can using the generic searching. I can use the generic searching for car type. Okay, for car type, but it's a generic. But generic is too far away, not even tested in AP. So I just give you a short introduction. But here, this sorting can work for car, work for student, work for even for integer, capital integer, the integer wrapper class. Any class can work for it. Okay, but that's too far. That's not even tested in AP. Okay, so we finished chapter 12, and hopefully when we do second semester, we'll come back to these topics. But right now, just keep in mind that uh, the these different object and class work for the GUI. And then maybe in your school, the teacher will give you some card game project. Don't be surprised. Usually you will have got one. Okay,
Okay.
is that okay? Any question for today?
No.
No, so we are actually quite late. So that's it for today. Is that okay?
Yeah.
Okay, good night then.
Good
And
night.
and
Thank
then
you.
work on your projects. Okay, I'll give you
Okay.
project 6 as well. But work on it one by one. And if you have question, you can call me. Okay.
Okay.
Make sure that you understand because we are moving to AP now. Okay.
Okay.
Bye now.
Bye-bye. Thank you.
Bye.